and welcome to Friday's edition of Cracking the Cryptic, where today we've got a puzzle by Lish Desh for you. This one's been recommended by our Discord server and the good folks over there, and it's called 42, 43, 44. And if you're listening carefully, you'll know that my anti-aircraft rocket did not hit Maverick, who is still flying past outside. Why is it called 42, 43, 44? Well, I guess it's because there are some enormous cages that I've seen in this puzzle. In particular, there's a 42, a 43, and a 44, as well as some other big cages. So, lots going on. I'll read you the rules in just a moment. A couple of things to mention first. Now, I watched Mark's video last night. His video that came out last night. I watched it this morning with interest. He solved a puzzle by Samantha Mukherjee, and it was a beautiful looking puzzle. And I started to watch the video, and I was like, Mark, I wouldn't do it this way at all. Literally, I would have done it in a completely different, with a completely different path, looking at very different things. So what I'm planning to do actually is to record my own solve of that puzzle, and I'm going to put that up on Patreon. So if you're a patron of the channel, hopefully you'll be able to watch that this evening. I'm absolutely intending to use a couple of different tricks just to see whether or not there is a different path through that Sudoku. So yeah, look out for that there. Now the other thing I really want to commend to you is Clover's setting video, which we released on the channel this morning. It's just a superb video. That's what I'll say to you. And the comments have been amazing. I mean, many people describing it as this is the TED Talk on how to set Sudokus. And other people calling Clover the Clever, which is obviously true. But I think the video is incredibly engaging, and if you have any interest in setting whatsoever, you'll find very few ways more pleasurable to spend an hour. So have a look at that and let us know what you think. Right, that's all said. Let's get on with the rules of Lish Desh's puzzle. What have we got today? We have got normal Sudoku rules apply. Clues outside the grid give the sum of the digits along the indicated diagonal, and digits along such a diagonal may repeat if allowed by other rules. So what that's telling us, for example, is that those 5 cells have to add up to 22, and we can repeat digits if we don't break Sudoku rules. So for example, those 2 squares could be the same, but those 2 couldn't be because they're in the same box of the Sudoku. In cages, digits must sum to the small clue in the top left corner of the cage, and digits cannot repeat within a cage. So there are, you can see there are enormous cages in this grid. So there must be 8 cells in this cage. I'll reveal how I know that in a moment. But those 8 cells have to add up to 44 without repeating a digit. And if you know the secret, you will know something, or 1 or 2 things about that cage already. So do have a go. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking. Now, do I start off with the secret here? I'm very tempted to. Let's deal with the secret. I mean, the puzzle's called 42, 43, 44, so it must be about digits that are missing from these enormous cages. So if we highlight any whole entire row of a Sudoku, any complete column, or any complete box, we know that if we fill it in properly, will contain all the digits from 1 to 9 once each. Add up those digits, you get 45. And 45 really in Sudoku terms is the equivalent of 42 in Hitchhiker's Guide to the Galaxy, because it tells you so much about everything. Let's revisit this 8-cell cage and think about it. What does it mean? Well, we know if it was a 9-cell cage, because it could contain no repeated digits, it would add up to 45. Therefore, an 8-cell cage must be missing exactly one of the digits 1 to 9, and that digit must be the difference between 45 and 44. So it's 1. There is no 1 in this cage. And similarly, if that's an 8-cell cage, and it is, there is no 2 in the 43 cage. There's no, that is an 8-cell cage. There's no 3 in the 42 cage. And that tells us something straight away, look, about column 5 of the grid. If there is no 3 in this cage, and there isn't, the 3 in column 5 must be at the bottom. Similarly, I suppose the 2 in column 4 must be at the bottom. Now you can also see, look, loads of 45 cages dotted round the grid. So they, you know, we don't even have to count. We know a 45 cage axiomatically because of the rules and the fact we can't repeat a digit in a cage must have 9 cells. So I'm wondering whether we have to look at geometry to start this. For example, this square is catching my eye, the sort of cell sticking out from the 43 cage, because whatever digit I put in that cage, this cell, sorry, whatever digit goes in this cell, we know must appear in a 45 cage because the 45 cage contains all of the digits. Well, but this digit can't go in those 5 squares and it can't go in those 2 squares. So this cell has a mirror in one of these 2 cells and therefore appears in one of those 3 cells. And I don't know if this is what we have to do, but it strikes me as likely that it's going to be this sort of thing that we're going to have to think about. So let's just take a moment and see whether we can spot anything else. The other thing I suppose I should look at is these little killer clues, which I've not even thought about yet. In fact, now I've distracted myself and I'm going to look at the little killer clues. So, have we got anything useful here? No. No. 1, 2, 3, 4, 5. No. I mean, but the basic trick I do with little killers is I find the approximate average of the cells. So you can see this is a 5-cell diagonal summing to 22. So the average is very slightly over 4. Well, the average digit in a Sudoku is 5. So this isn't really interesting. It could have a mixture of high and low digits, and there's nothing really forcing the digits on it to be one way or the other. 19 in 3 cells is very slightly high. You can't put a 1 on a 19 diagonal because you can't put double 9 on it. That might be useful. No. Can't put a 9. Oh, sorry, can't put a 1 on this 19 diagonal. Again, I'm not seeing anything there. Another 5-cell 22 diagonal. Now, what about the main diagonals? 37. So 37 divided by 9 is very close to being 4. So again, this diagonal it's pretty average. It's let itself down. And this 54 diagonal, oh, it's high in the other direction. It's averaging 6, which is also pretty close to 5. So the little killer clues I am concluding are most likely to be used later, which is a bit daunting because whenever you get puzzles like this with these enormous cages, I'm never quite sure where we should look. Hang on, column 9. We can use the secret on column 9 to get the value of those 3 squares. We've got 27 in those 6 squares, so those 3 must add up to 18 to give us 45 overall. We've got 17 there, so these 6 cells add up to 35. Those 3 squares add up to 10. Those 6 cells add up to 35. Yeah, we can carry on like this, but we're getting nowhere. Bobbins. I'm going to need a special pop filter on my microphone, I think, for puzzles like this. What on earth am I meant to do? So it must be something to do with these cages. There must be something else we can do to try and... You see, for example, I'm now noticing that 1 in row 7 is a little bit restricted. It's got to be in one of those 3 squares because it can't be in the 44 cage. But the problem is that it can absolutely be in all 3 of those positions. And I've got no very good way of pencil marking the 1s into just those 3 cells anyway. 13. There's a little point there, look. 13 has these 3 cells have to appear in the 45 cage. Well, where can they go? They can't. Whatever goes in these 3 squares cannot appear in this column. So those 3 squares are the same as those 3 squares, which is definitely worth recording. or is it? So these 3 squares are the same as those 3 squares. No, I'm not seeing what that means. I've done this diagonal. I'm struggling here. What on earth are we meant to do? 17 here is the same as the 13 there. That 17 has to appear in that 45 cage. So those 3 squares must appear in those 3 squares, I suppose. Now, that's got me wondering about row 8 and row 9. So now I've got 13, 17. That's 30, 45, 40, 54. So these squares have got to add up to 36, which is absolutely hopeless. This is interesting. This is interesting, and I'd missed this, but look. Those squares are all in cages, enormous cages. Right, this feels good, actually. I'm fairly confident we might be onto something, because I can see now I can get the value of these 3 squares. Now, how can we get the value of these three squares? Well, by doing enormous sums is basically how we're going to have to do it, because we know the value of this blue box I've just drawn. Maverick. Now, the value of this big blue box is 1, 2, 3, 4, 5. So there are 5 enormous cages in it, which... Okay, so if these were all 45 cages, 5 lots of 45 is 225, but they aren't, because this one is missing 1, this is missing 2, and this is missing 3. So we've got to take 1 plus 2 plus 3, which is 6 of 225. So 219 is the value of this big rectangle here. 219, but we know from the secret what the value of all of these cells is, because of course that this is this is 6 complete columns of the Sudoku. Now each column individually adds up to 45, so 6 columns adds up to 270, which means those squares at the bottom of the grid add up to 270 minus 219, which is 51. Which means that those 3 squares, which are the ones I'm hoping are going to be interesting, add up to 51 minus 13, 17, 45. This is beautiful. Right, so these 3 squares add up to 6, because these 9 squares add up to 45, just using the maths of these adding up to 13, these adding up to 17, those add up to 15. So these add up to 6, and the only way of doing that is 1, 2, 3. And in fact, the only way of doing that, yes, given we know the 2 is in this column, these 2 can't be 2s, so that must be 2, that must be 3 by the same logic, this is 1, and we have 3 digits, and we are off and running. It's taken a while to get them, but at least I've got something in the grid now. So, what can we do with that? We can. The 7 diagonal, maybe. This top digit has to be on the high side. It can't be 1, 2, 3. So this is 4, 5, or 6. This square is 1, 2, or 3. Which is all very well, but doesn't seem to do anything. We can... so hang on. Now there's a 1, 2, or a 3 in the 13 cage. Well, that's not surprising, actually. No, sorry, that's not surprising. This square has a lot of options. Oh, good grief. Sorry, I thought this would be a breakthrough. I've got a 1 now on the 22 diagonal. You're right, that's not useful. At least it's not useful yet. What on earth am I meant to do now? What do these add up to altogether now? I'm wondering if I can get the value of these squares. It was 51 for there and 9, 60. So these add up to 30. Ah, okay. Nearly very interesting. Yeah, so just think about the maths of the bottom 2 rows in case that was unclear. I know this row adds to 45 and this row adds to 45. So together they add up to 90. But I know from the maths we did earlier, those add up to 51. 51 and 9 is 60. So these have to add up to 30. Now, if this is 4, the unfortunate thing about that is I could still make these 3 squares add up to 26 because I could go double 9 and 8. Although actually that wouldn't work because that would break this square. So, we have a little bit of a deduction here. This cannot be a 4 because I can't possibly make those 3 squares add up to enough if that's a 4. So this isn't a 4, which means this is not a 3, which now means there's a 1 or a 2 in the 13 cage. And there's still pressure on these 3 digits. Now, yeah, I think this square is the one we have to focus on, because this cannot be a high digit. If this is a high digit, this has to be a low digit, and it can't be 1, 2, or 3, so this cannot be 8 or 9, which means that it has to be relative. It can't be very low, or I'm going to have problems again. Like if this was a 4, these 2 would add up to 10, and these 2 would have to add up to 20, which is impossible. 5 and 6. Yeah, 5 doesn't work either. This has to be at least equal to 6. Unfortunately, it can be 6, because if it's double 6 there, we could go double 9 here, and that would add up to 30. So this is at least 6. Or, well, it is 6 or 7. It can't be 8 or 9, because that breaks this square. So this is 6 or 7. This is 4 or 5. And 4, 5 in the 9 cage is beautiful. That becomes a 4 or a 5. That means that's got to be 1, 6 in the 7 cage, because it can't be 3, 4 or 2, 5. That means that the 11 cage is going to have to be, no good. That's got to either be 2, 9 or 3, 8. But there's no, right, what there is not in the 11 cage is a 7, because if there was a 7, there would be a 4, which there can't be. So 7 is at the top, which means 7 is not in blue, which means 7 is not down here, which means that 7 is not in blue. I don't know. I don't know if that means anything. It probably does. Try to withhold your shouting while I give myself a moment to think about it. So these 2 squares I think have to be very high. Possibly, well, if it was double 8 here, that would be 16. I'd need these to add up to 14, which they can't. So we know there's at least 1 9 in these 2 squares. So in fact, yeah, the maximum value of those 2 squares is 13. So the minimum value of these 2 squares is 17. So they either have to be 8, 9 or 9, 9. Which, now what's that doing? Is that doing something to the 17 cage, which now can't have whatever this digit is in it? Okay, yeah, so there's now a virtual 8, 9 pair in column 8, because I know the 17 cage has not got a 7 in it. It's not got this digit in it, whether that's 8 or 9. Now, if it didn't have the other of the digits 8 and 9 in it, then its maximum value would be 6 plus 5 plus 4, which is only 15. So the other 8, 9 is in here and joins its friend here to make a pair. I'm not actually sure that's useful, but I suppose that means that there's an 8 and a 9 in one of those 3 squares as well. But we don't know where it is. Ah! And there doesn't have to be... I keep going around in circles here. This is not easy. I think the Discord folk suggested that this was a broadly average puzzle. The problem is that they're all geniuses, so maybe it is average if you're a genius. I don't feel like it's easy. The other probability is that I'm missing something straightforward here, in which case, apologies. I am not trying to miss anything. Of that I can assure you. So, what do we do now? Okay. Row 9. Yeah. No. Yes, it's right. It is correct. Where do 1, 2 and 3 go in row 9? They can't go in those squares. They don't seem to be able to go in those squares, so there are only 3 squares left. This one, and this one. So those squares have got to be 1, 2 or 3. Ah, beautiful. Now this can't be a 1, because if this is a 1, you have to put 1 up here in the 17 cage, which will require a 7 and a 9 to join it, and there's no 7, because the 7 seems to be over there. So this is not a 1. So now there's a 1 in one of those 2 squares, which... Now what does that mean? So now I've got a 2 or a 3 in the 17 cage. So the other 2 squares are either adding up to 15 or 14. If they're 15, they've got to be 6, 9, because they can't be 7, 8. If they're 14, it looks like they might be able to be 5, 9 or 6, 8. Wow. Right. So I've got a 1, 2, 3 triple. But I still got to place 4, 5, 6, 7, 8 and 9. I think I'm missing something here. This is quite tricky. What about the 13 cage? Let's have another think about that. So we've got a 1 or a 2 in it. So it's either the other 2 digits are either adding up to 12 or 11, and they've got to go in here. Now that might be interesting. So what I'm actually looking at is those 2 cells. Yes, this is interesting, I think, because what we cannot do is select these 2 cells from 4, 5 and 6, because if we do that, we've broken the row. We're going to have to select 4 different cells from 3 different digits, which won't work. So the maximum number of these 2 cells that can be a 4, 5, 6 selection is 1. Now, I think there must be 1, because if there isn't, none of these squares can be 1, 2 and 3, and if they couldn't be 4, 5 and 6 either, they'd have to be 7, 8 and 9, which might look possible, but when you add even 2 of those digits together, you definitely get higher than 13. You can't add 7 and 8 and put -2 in the other square. So one of these squares has to be 4, 5 or 6, and one of them has to be 7, 8 and 9. Now that makes me think it's going to be very hard to put a 6, well, it's impossible to put a 6 in this domino. Because if you do put a 6 in this domino, let's say we put the 6 here, the other digit we know has to be selected from 7, 8 and 9, well that's going to require 7, 6 and 0 in the 13 cage, which won't work. So the digit that's selected from 4, 5 and 6 in this domino is not a 6, it's a 4 or a 5, so it joins its friend here. And there is a virtual 4-5 pair in these three squares, which means that this square is not 5 and that is a 6. And that is very, 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 very hard. And that's a 1. And now we are off and running, maybe. I mean, it's beautiful, to be honest, isn't it? It really is clever. There may well have been an easier way of doing that, but I do like it. I really do like it. Now, I'm wondering now, can we just rule out... Yeah, hang on, we can just rule out 9. If there's a 9 in here, how do you make the 13 cage work? It's going to have to be 9, 1, 3, and you can't make this square 3 at the same time as it's 1. So you can see neither of those squares can be 1 or 3, so this would have to have dual personality, which doesn't exist in Sudoku. So there's no 9 in there, which means there's no 9 in here, which means there's a 9 in one of those two squares. Which means what? That means that I don't know where the 9 goes, I don't think. Sorry. I suppose I know there's a 1. I know there's a 1 in the 13 cage, so there's definitely a 1 up there. And we know it can't be 139, because if I put 139 in here, then where does the 3 go in the 45 cage? It has to go in this domino where it can't go. So this is not 139, this is either 148 or it's 157. And this square is never a 1. Whoopsie, I didn't mean to do that. This square is never a 1 because it's on the 19 diagonal. So these two squares are from 4s, 5s, 7s and 8s. Ah, got it. I've got it. Right. Look at row 8 again. And what digit can we not put in blue? The answer is 7. We know that 7 is not in blue, so 7 is not there. And if 7 is not there, where is it in row 8? It's got to be in there. Once 7 is in there, it joins its friend the 1 in the 13 cage, and the 13 cage is now 157. That is very, very clever. Wow. So that's a 5-7 pair, which means that's 8 or 9, I think. Let's get rid of the 9s pencil marked in the corner. So that means we've got one of these squares is a 2, 3. One of them is an 8, 9. So the maximum value of them is 12. So we've still got to put another 5 at least in as the other digit. So this square has to be at least equal to 5. That's a little bit restricted actually, because it's at least equal to 5, and it can be 6 or 7, but it can't be 8, 9 because there's an 8, 9 pair in the box here. So this is 5, 6, 7. There's a 5, 7 here. Ah, it's a 5, 7 here, so that's become a 4. That's a 5. That's not 5 anymore. I've now got a 6, 7 pair in this row. And I've got an 11. Don't forget little killers. Yes, little killers might be your friend, even though they don't sound friendly. This 11 is rather beautiful because it goes with its friend the 4. That gives me a 7 and a 6. Now the 6 must go in the 17 cage up here, which means it needs another 11 with it. Oh, so this is 2, 9 or 3, 8. Wow, okay. And we've got a 2, 3. Actually, look at, yeah, if you look at row 9, we've basically placed 6 digits all but. We've got 4s, 8s and 9s to place. So there's definitely a 4 in this domino, which means there's definitely a 4 in one of those 3 cells. Now, what do we do next? That is the question, and I don't know what the answer is. I can put 6. I've got to put 6 in the 45 cage. Look there. It can't go in those squares and it can't go in those squares. So there's definitely a 6 in one of those two squares. Which is nice, actually, because that fixes that that's a 1 and that's a 6. And that feels like it might be important, but I can't see how. So these squares now are from 1, 2 and 3, just to complete the box. But yes, this is good. The 44 cage can't have a 1 in it, so that's not a 1. We've now found a 2, 3 pair in column 7. This square is a 1. And boo sucks Maverick. You can fly by all you want, but I found the 1 in box 9. So 1 is in one of those 3 squares in the 45 cage. Which might be important. I don't know. This 11 cage, do we know anything about it? We know it's either 2, 3, sorry, not 2, 3, 2, 9 or 3, 8. I was just wondering about this diagonal, but I don't think, once we deduct the 1 from it, we're averaging very close to 5 again. Have I used the other little killers as... Well, this one is a particularly useless specimen. The main diagonals we know nothing about. That one can't have a 1 on it. So... Wow, I do not know. Hang on, let's just think. I've now got 5 digits in this 45 cage. So the digits I've not put in this cage yet are 2, 3, 4 and 5. So these squares... okay, so these squares have to include 4 and 5. Because we can't put 4 and 5 in any of those squares. Now we do Sudoku with 4s and 5s, and they go up there, joining their friend the 1. So this is a 1, 4, 5 triple. Don't put 1 on the 19 diagonal. Now look, what have we got here? We've got 1, 2, 3, 4 and 5 in column 7. So these squares are from 6, 7, 8 and 9. And that can't be 6. And do we learn anything more about the world from this? Now we know there's a 7 in one of those 3 cells, which I think we knew before. Ones and 6s. Here's a simple deduction. Good grief. Right. We have to put a 6 in the 44 cage. The only digit missing from the 44 cage is 1. Well, this 6 rules out all of those squares. That one doesn't seem to be able to be a 6. I'm not sure why. We seem to have locked a 6 into one of those squares. Oh, yes, I know why. It's because we needed to put a 6 in this 45 cage. Good grief. Right, so 6 goes here, which means 6 is in... Does that mean 6 is not green? It does mean 6 is not green, so 6 must be in one of those 2 squares, I think. So that means that that square is not green then. So whatever this digit is appears in there, and it appears in one of those 2 squares. And I tell you something, that square suddenly acquired potency now, because this square cannot be a 1. And this square cannot be a 6. So where does this square appear in the 44 cage? And it must appear in the 44 cage because it can't be a 1, and it's not this 6. So this square is the same as that square, I think. This is going to get complicated now. I'm just going to make that red. This will appear with a red flash in it. Now, right, now, that seems to be suggesting that this square has to be, this square, I should say, has to be a 7, 8, 9, because it has to be the same as that one, which apparently has to be a 7, 8 or a 9. So this is not 4 anymore. This is 7, 8, 9. It's not 7. There's a 7 in the box. So which means that's not 7. So now we've got either 8s in here or 9s here. We've got an 8, 9 pair in column 1, which means these squares are 2, 3, and 4. It means that... hang on. I've got an 8, 9 pair in column 7. So now, oh no, I haven't done anything. I've learnt a bit more about this 45 cage. I was wondering about the stuff at the bottom. But the 45 cage now, we've now got 1, 4, 5, 6, 7 in it. So those squares are 2, 3, 8, and 9. Whoopsie. 2, 3, 8, 9. You can see that doesn't seem to be doing very much at all. Those 3 squares to complete the column have to be 4, 5, and 7. And this can't be a 4 because we see it sees 4 in its box. This is very cute. So now 4 in column 6 is either here or here, both of which are in the enormous 42 cage. So what digit can you not put in that strip of digits? Yep, 4. So if 4 is not there, 4 is in one of those 3 cells, but it doesn't seem to be able to be here. So I think that means that's a 4, and that means that's not a 4. And now we need these two to add up to 11 again. So it's a bit like the ones we've got over there, or here, or wherever it was. We've got 2 cells that have to add up to 11 that are either 2, 9 or 3, 8. We've got a 4 on this diagonal now. So those 2 squares are adding up to 5. These add up to 17. That's relatively low. So the minimum value of those 2 squares... here's something. The minimum value of these 2 squares is 14, because even if I make that a 3, these have to add up to 14. Well, this square definitely can't be a 2 or a 3 then, which means that square must be a 2 or a 3, and that... no? Well, it's still a bit better. I've now got an 8, 9 pair in this box. Oh, I see. This is gorgeous. Right, yeah. This square now can't be 6, 7, can't be 8, 9. Yet this domino, or not really a domino, this sort of strange offset diagonal arrangement, has to add up to at least 14. Well, the only way we can do that is if this is 5 then. So that must be 5, because otherwise we won't be able to make the total add up to enough, given that we can't put anything higher than 5 in this square. So that must be a max out number to get us to 14. This must be a 3, otherwise we don't get to 22. I'm just going to double check the maths on this. 8 and 14 is indeed 22. This 3 gives us a 2 here, which means that must be a 9 to make sure those 3 squares add up to the right amount. That's an 8. So this now is 2, 6, 9. This 9 is giving me an 8 here. That's doing what? Well, now we complete the 11 cage, I suppose. Let's try and do things in a simple way. Those 2 squares are 3 and 4. I've got a 3, 4 pair here and a 2 in the row, so this square can't be 2 or 3. 8 goes in the red flash because of this 8 here, so that square's become an 8. That must be a 9. That must be an 8. And that must be a 3. And that means there's a 3 in one of those 3 squares. And these 2 squares must be, what's that, 2 and 4? And these squares have got to be 5, 7 and 9 to complete the box. And all of a sudden we have a little bit more progress again. Ah, look, we know what they are now. What are they? They are 3, 7, and 8 in some order. This can't be 3 because the 19 diagonal won't work. So this is 7 or 8. Ah, this is interesting. This can't be 4 because those two would have to add up to 15. And given this is a 7 or an 8, this would have to be a 7 or an 8, which it can't be. So that's 5. No, it's okay. It's just okay. These have to add up to 14, and the only way that will work is with 6 and 8. Which means we get rid of stuff from those squares, we get rid of stuff from those squares. We've got a 6 here, which is fixing a 6 in box 1, which means we get a 6 in one of those squares. And well, now we must know green is 8 or 9, I think. Because whatever green is must be appearing in one of those two squares, so it's got to be 8 or 9. So there's an 8 or a 9 in one of those squares. I don't know if we know which one. We probably do, but I can't see how to tell immediately. The 8, 9 is probably helping us with this diagonal, I suppose. Or is it? Maybe, yeah. If this is 5, how do you make those add up to 14? You can't do it. Because you can't use 6, 8. That's gone away as an option. You can't use 5, 9 because you've started the sequence with a 5. So this is 7. These add up to 12 then. So this is 3 or 4. And that is Bobbinsworthy, because I don't think I can do that. Oh, right, okay, so we're going to have to think about something different. What should that different thing be that we think about? What have we not used? We've not used... I don't know, is the answer. We have punished everything quite liberally in order to get to this point. We've got a 5 here, so that gives me a 5 there, and a 1 here. That means there's a 5 in one of those two squares. I've done this diagonal. I don't think I can do this diagonal. This diagonal is the worst diagonal in Christendom. This diagonal is done. That diagonal is done. Do we know anything else about anything here? That's the question. Yes, okay, I do actually. I've just spotted something in column 6, which is where does 5 go? I've now got 5s in those two positions, so I can't put 5s in there. So the only place for 5 now is here, which means that I've now got a 4-7 pair in my, whatever cage this one was, a 42 cage. So I've got a 4-7 pair. There's no 3 in this cage, but there is every other digit. So one thing I can quickly say is there is definitely a 9 in these 6 squares. And if there's a 9 in those 6 squares, there is not a 9 here. So that's a 7, that's a 9. And that's beautiful, actually. Oh, this is absolutely gorgeous. Right, look at this. Let's use the 43 cage now and think about that, because that has not got a 2 in it, for sure. But it must have an 8 and a 9 in it, and that 8, 9 can't go along this big stem. So these two little squares must be an 8, 9 pair, and this one can't be an 8. So that's a 9, that's an 8, and that becomes a 4, because we said they had to add to 12. That 4 gives me a 4 and a 2. A 2 goes in here. That's no longer a 2. These squares have got to be 3 and 9, I think. These squares have got to be, 5, 7s and 8s maybe. Bother. And these squares are 1, 5 and 7, which is also botheration. Now this 4 though, that keeps us going. 4s and 1s go in the grid. Those two squares are now 1, 5 pair because of these cells. Now 8 can be ruled out of this one. 2s, 3s and 9s. The 19 diagonal here is done. This diagonal is done. I've got quite a lot done in this diagonal, so I'm going to add this one up. We've got 11, 22, 27. We need 10 into those squares. So if this is 7, we need a 1 and a 2. Oh, 2 and a 1. That might work, actually. If this is 4, these two have to add up to 6 without using 2, 4. So they'd have to be 1, 5. So there's always a 1 in one of those two squares, whatever this is. But I don't think we can do better than that, unfortunately. So where else should we look? We shall look at this row, maybe. We need 3, 7, 8, 9. Nearly. That can only be 8 or 9. C's 3, 7 in the column. And that can only be 3 or 7, I think, because it sees 8, 9. So that's not 3. So now we've got an 8, 9 pair here. So this isn't 9. This is not 8, 9. And now I've got a 2, 3, 4 triple in this row, which I don't believe it. Does nothing. Good grief. I don't believe it. I'm lost for words. Okay, let's look at row 6. We've got 2, 3s, 4s and 7s to find. So, that's useful. Well, what's this? There's a 3, 4, 7 in column 5, so that's a naked single, which I certainly didn't spot. That's not 2. That means the 2 goes here. That's lovely. That gets me a 3 and a 2 and a 2 and a 9 and a 9 and a 3. And it does a 3 and a 4 and a 3 and a 4. Now, hang on, what have we got here now? This square's a 4 or a 7, I think. We can't rule either of those out using the totals. We can't use Sudoku. But we've got this diagonal still, haven't we? Yeah, this is important. This can't be 7 now, because that would need a 1 and a 2 on this diagonal. So that's 4, that's 7. These two squares are a 1, 5 pair, which doesn't seem to be resolved. But that probably means I'm missing something here, because it feels like they should be resolved. Not sure. Okay, so let's have a think about the remaining digits in this box. We need 6, 8 and 9. So this square is a naked single. That can only be a 6, I think. It sees 8, 9 in the column. Now that fixes those squares, gets rid of 7 from these squares. I've now got a 1, 5 pair out of nowhere, which gives me an 8 here. This is an 8 or a 9. Don't know which. Still resisting. You irritating thing. Now hang on. This column needs a 6 in it, so that we can do. So this square should be 3, 4 or 7, so it's 3 or 4. Oh, nothing's working. Oh, is it? Maybe it's the other diagonal. Still got quite a lot of real estate unfilled there, though. I'm not sure about that. Are there any other diagonals I've not used? Oh, there are, actually. Yeah, I'm seeing some. This 22 diagonal I've not used. 14 into those squares, so these have to add up to 8. Oh, goodness, I thought that didn't work. But there is one version that does work, and that's 5 here and 3 here. Thank goodness for that. So that's filling in some stuff. Although not very much by the looks of it. Oh, no, hang on. I'm maligning things unfairly. All of those go into the grid. That's got to be a set. I've got an 8, 9 deadly pattern, have I? I see, and that's going to get resolved by this diagonal. Beautiful. Okay, so we're heading towards 54. We've got 20, 32, 42, 45. We need a 9 here. Lovely. 9, 9, 8, 8, and I think that is the correct solution. What a great puzzle. That was hard, though. That was hard. I protest that was difficult. I'm going to be fascinated to see the comments. It's very possible I've missed all sorts of things there, but it didn't feel like I was completely stupid. And let's just think about some of the logic we had to use. The start was difficult, I think, without being monstrous, because I had to spot this, and then I had to notice this enormous rectangle. Now, you know, if you give it enough time, everyone's going to get that probably, but I don't think it was easy. And then, I can't quite remember, but I had to do quite a lot of work on these possibilities. And eventually, I think the thing that really kicked us into gear was managing to well, it was noting that there had to be a 7 in this domino, because there couldn't be a 7 in these squares, these two squares in row 8. And that gave us the composition here. But even after that, there was still quite a lot of trickery to do. We had to do some stuff that was clever with this cage. And we had to do... And then there was the beautiful stuff involving these columns. And this 9-8 forced into those squares. That was lovely. And the red flash. Do not forget the red flash. The red flash was also pretty important. So there is just what I would describe as a whole heap of logic to be done to get through this puzzle. It's very impressive indeed. Let me know in the comments how you got on. Let me know what I missed. I always enjoy reading that. And we'll be back later with another edition of Cracking the Cryptic.